Hello guys, in this series I will teach you how to code in x86 assembly. I don't know much, but I will try to teach you what I learned. But first we need to understand how the computer works under the hood. Assembly language is as close as you can get to talking directly to your computer's brain, the CPU. So let's talk about what you need to know. Let's start with the CPU, the central processing unit. Think of it as the brain of the computer. It processes instructions, does calculations, and controls data flow. In x86 assembly, we're specifically working with the Intel x86 architecture, which is one of the most common CPU architectures. Now, every CPU operates with instructions, which are tiny commands it understands. These instructions tell the CPU what to do, from moving data around to performing mathematical operations to making decisions. And in assembly language, you'll be writing these instructions directly. Next, let's talk about registers. Registers are very small, fast storage locations inside the CPU itself. Think of them like some little boxes that store information inside of them. It is clear that they are not boxes, but it will be easier to think of them like they are. In x86, you'll encounter common registers like EAX, EBX, ECX, and EDX. Each has specific purposes and, depending on the CPU model, these registers can be 16-bit, 32-bit, or 64-bit. For example, EAX is the 32-bit version of the AX register. Each of these registers plays a unique role. For instance, EAX often holds results from calculations, while ECX can be used as a loop counter. When you code in x86 assembly, you'll often move data in and out of these registers to perform your operations. Now let's discuss memory in the stack. Memory is where data is stored, but it's a bit slower for the CPU to access than registers. When you need to store larger pieces of data or more persistent information, you'll use memory. The stack is a special area of memory used for storing temporary data. You can think of it as a pile of plates. You add data to the top and remove it in the reverse order. This is known as last in, first out, LIFO. In assembly, you'll use commands like push and pop to add and remove data from the stack. At the heart of x86 assembly are instructions. These instructions are commands that tell the CPU exactly what to do. Some common x86 instructions include MOV to move data between registers or from memory to registers, ADD and sub for basic arithmetic, and CMP to compare values. There are also jump instructions like JMP, JE, jump if equal, and JNE, jump if not equal, which help control the flow of your program by telling it where to go next based on certain conditions. Lastly, let's cover flags. The CPU has a special register called the flags register that stores information about the results of operations. For example, if a calculation results in 0, the 0 flag, ZF, is set. Or if an overflow occurs, the overflow flag, OF, is set. To sum it all up, here are the essential concepts you need to know for x86 assembly. Understanding the CPU and its instructions, knowing how to use registers, working with memory and the stack, mastering basic instructions, and understanding flags. By grasping these basics, you'll be ready to start writing simple x86 assembly programs. Thanks for watching. If you're ready to dive deeper, join me in the next video. Let's start coding close to the metal.